So today's video is to study a room. So we are having a room in which we have fixed air conditioner, and this air conditioner is placed on the window. So let there be a window air conditioner which is taking care of this room. And if it is very hot summer, then the moment we want to use the room and start the air conditioner, the air of the room is 40 degrees centigrade and is represented by alphabet R. So R is representing the room condition, and they can be in fact any condition is represented with the help of two state conditions, temperature and anything else. So 40 degrees centigrade is the dry bulb temperature. So if we see 40 degrees centigrade, this is the dry bulb temperature. We can assume any relative humidity or specific humidity, and we can then set a point which can be represented by condition R, and this R condition is actually representing the condition of the room air when the air conditioner has not yet started. So let us start the air conditioner, and if we start the air conditioner, then what will happen? If you see the air conditioner, what is there is most of the time the air conditioner has got a big portion in which there is air which is going in, which is not coming out. Air is coming in, and then there is a partition. There is a partition in the window air conditioner which does not allow the air which is going in to go outside of the room. So this is the wall of the room. There is a partition in the air conditioner. So the air is trapped inside this area, and there is a cooling coil. So this cooling coil will do something with the 40 degrees centigrade temperature air, and the temperature of the air will go down. If the temperature of the air goes down and it is processed means its condition is changed, and therefore the cooling coil does something to the air, and therefore the air passes through area and is supplied by this portion of the air conditioner. If you see your air conditioner, you will find on the right hand side there is a grill from which the air is coming out. Left hand side portion is the big portion where there is a cover, and inside the cover there is a filter here. There is an air filter here which is regularly to be cleaned, which should be cleaned by you or anybody, otherwise it can give you contaminated air. So air comes in, gets filtered here, and then passes through the cooling coil, and then its condition changes, and then it is supplied by the supply grill to the room. So let the supply air will be having a condition S. So S is what is S? S is the supply condition of the air. R is the room condition of the air. And if cooling coil has got a temperature TA, if the cooling coil has got a temperature TA, then TA can be, see, I tell you what, the cooling coil is an equipment, it is not air. Cooling coil, the evaporator, is a equipment, it is a heat exchanger, it is not air. So when we talk about psychrometric chart, we write down any point on the psychrometric here. What does that represent? Condition of air. But if we take this TA, the temperature of the cooling coil, we set it here, supposing if it is 4 degrees centigrade as represented by the temperature that I have chosen. So TA is not representing any quality air or anything about air. It is talking about the cooling coil temperature. So what is a cooling coil? Cooling coil is an apparatus. Cooling coil is an apparatus, and therefore this apparatus is going to do something which I am going to explain. So what will happen is that this apparatus, the air R will come, and then it comes into contact with the coil, what will happen is, first of all, it will lose its temperature. So the temperature of 40 degrees centigrade will go on decreasing like this, go on decreasing like this, go on decreasing. So these will be the state conditions which will now be followed by the air without changing its specific humidity. So first of all, the process will be that the air will not change its specific humidity and it will go on coming to this particular point. What is this particular point which I have explained in this is sensible cooling, as I have explained you in my previous lecture of dry bulb wet bulb temperature and dew point temperature, WBT and DPT. So this particular point is known as DPT of R. What is? This is the dew point temperature of R condition. तो आर कंडीशन का ड्यू पॉइंट टेम्परेचर क्या है, ये अगर हमारे पास यहाँ कंडीशन होता है इसका ड्यू पॉइंट टेम्परेचर क्या होता है, ये यहाँ कंडीशन इसका ड्यू पॉइंट टेम्परेचर क्या होता है, ये ड्यू पॉइंट टेम्परेचर पाने का तरीका क्या है, गो ऑन अ हॉरिजॉन्टल लाइन wherever it cuts the saturation curve, that is the point at which it becomes 100% saturated, and if we further lower the temperature of this air, the water will start condensing. That is what a dew will start getting formed. So the cooling coil, what will do, its temperature of the room air will go on decreasing here, and as the temperature has come here, still the temperature of the cooling coil being very very low, which is 4 degrees centigrade, it will now start dehumidifying the air like this. It will decrease the humidity of the air, and therefore what will happen is certain amount of water vapor from the air R will get condensed, and this condensed water vapor will now get collected inside the tray which is at the bottom the air conditioner, and this water vapor which has got condensed is actually a dew which has got condensed. So there are two things. One is a dew formation, another is coil. So the coil is an apparatus. What coil is an apparatus? So if we want to write down the temperature of the cooling coil here, we will not say evaporator temperature, we will say apparatus dew point. What is apparatus dew point? It is an apparatus which is evaporator, which is going to produce dew points as it condenses. So there will be several dew points which will be formed, and therefore this particular temperature will not be known as evaporator temperature but will be known as apparatus dew point from now onwards. So TA is therefore now defined on the psychrometric chart as one of the new thing which we have learned today is apparatus dew point, which is not the temperature of air, it is the temperature of the cooling coil. Well, it is related with apparatus, it is related with dew point which is achieved of the air, and therefore it is known as apparatus dew point. So in this way we can say the air is now changing from R condition and then forming a dew point here, then again condensing, again temperature is reducing, again condensing, then temperature is reducing, because the temperature is very very low. So 40 degrees centigrade air will go on giving heat to the cooling coil, and therefore the condition of the air. Now this particular points here are the condition of the air which is changing from R. So R is changing up to here and then gradually following this line and trying to come to this particular point which is the coil temperature, which is apparatus dew point. So the room air will try to or can go on changing its condition from R to condition A. So this is A. So A condition. So if we want, in actuality, you can make a line like this and then make steps and come here. This is the actual process happening. Or you can draw a straight line from here to here. So this line is a hypothetical line, theoretical line which can be produced without considering the actuality. And this process line is the line in which we can say the air which is to be processed is becoming equal to the temperature of the cooling coil. The room air the room air as it comes in contact with the cooling coil, which is at 4 degrees centigrade. So 40 degrees centigrade temperature air is converting itself into 4 degrees centigrade temperature. So what is TA? It is the temperature of the cooling coil, and by fortune, which is not actually practically possible, all the 40 degrees centigrade air is converting itself into 4 degrees centigrade air. So this effectiveness, which is not possible, of conversion of 40 degrees centigrade to 4 degrees centigrade can be shown on a line which is represented by this particular line, which is cooling and dehumidification, where the temperature is falling down and humidity is falling down. So this is cooling and dehumidification process, and this particular line is known as something which I will explain you later on. So I hope this particular thing is clear. Now, in order to define new parameters on the psychrometry chart, I have to now shift to another particular issue. Here I am looking at the same room in a very different perspective, very different thought, and that thought is that this room has got number of informations which I am going to gather. What are the informations? Are that this room has got a door, this room has got a windows, this room has got fan and a tea maker, it rooms has got a light and a television, etc., and also has got an air conditioner. Okay, this room is made up of wall, and the window is having glasses, the door is having wooden panel or glasses. So this room has got a certain structure. Okay, number one. Number two is that this room, as it is being constructed by a civil engineer or an architect, will be having a certain orientation. What is meant by orientation? That north, south, east, west direction of the room. So if we can, in this case I will say this particular wall and this window is facing east. This particular wall and windows are facing west. The AC and this particular wall is facing north, and this wall is facing south. So the orientation of this room could have been shifted if the whole room is rotated or designed, but when it has already been constructed, it is now presently there, we cannot change the parameter of the wall, we cannot change the orientation of the window, we cannot change that the fan will not be there, or the light and people will not be coming here. So this figure. So this person which is standing here can be number of person or a single person, which is known as occupant. The people who are occupying this room are known as occupant. Now, once we know that this room parameters of the room are now there are a number of people which can sit here, number of fans are there, can be calculated, number of windows also can be calculated, area of the window, area of the door, area of the south wall, area of the east wall, area of all the walls can be calculated, and therefore, and we know that the temperature outside of this particular room, which if it is situated in Hyderabad or in Delhi, the maximum temperature of the city is also known. So we now have fixed few things. What have we fixed? We have fixed informations. What are those fixed informations? That there will be a certain amount of heat produced by the fan, heat produced by the equipment that we are using, and heat which is coming through the wall because of the radiation falling, because of the temperature differential from outside and inside, because of the heat radiation coming from the glass, or the temperature differential from outside and inside. And and sometimes the door can be opened and closed, so a certain amount of air can always get inside. The amount of air can always peep in. So that is, infiltration will also be there. We cannot avoid infiltration. And the air conditioner will also not be using the same air coming from the room and delivering it, but also be using air which is coming from outside, which is very high temperature and has to be processed. That particular air is known as fresh air, room air, if it is again going to the room, is known as room air, but air which is coming from outside is considered to be known as fresh air. Now if we think about fan, the fan, does it produce any humidity? The bulb will produce any humidity, or the heat which is coming from outside is going to produce any humidity? No. So there are certain things which we know are not humidity based, they are temperature based. So we will collect all these type of heats which are not contributing humidity but participating in heat addition to the room. So those type of heat, we can say that these are sensible heat, and can say X1, Y1, Z1 type of sources are there, which we add up and we say this is a room sensible heat. What is a room sensible heat? It is the heat which the room is going to get from various sources in the form of temperature increase and not humidity increase. Let us assume that to be 40 kilowatt for this particular room. So I am assuming 40 kilowatt for this particular room, which is just sensible heat, the heats which are going to contribute in the addition of temperature increase. Now let us talk about this person. The person which is here will always be exhaling air from his mouth and dissipating water vapor from his body. So a certain amount of humidity addition is there because of the occupant. The tea maker can also produce a certain amount of humidity which can be added inside this room, and the air which is coming from outside from fresh air or through infiltration will also be adding from certain amount of humidity coming from outside. So these are the four sources which are now visible, which are going to add into the humidity of the room, whereas other sources are not humidity based, they are temperature based. So we can say there is a certain amount of latent load. The humidity load is known as latent load. Anything which is going to add into the humidity of the room will be known as latent room load. So let the latent room load be X2, Y2, Z2, and then it can be added to be room latent heat. So there is something called room sensible heat, there is something called room latent heat. Let us consider that room latent heat to be 10 kilowatt. So I have assumed a room where things are fixed. The room sensible heat is fixed, the room latent heat is fixed. Means the appliances and people, number of wall, everything which is going to contribute will always be 40 kilowatt or approximately. Similarly, room latent heat can also be approximately be said as to be at 10 kilowatt plus minus. Now these things, when they are fixed, we will say there is another thing which is fixed, and that is what is room sensible heat factor. So room sensible heat, room latent heat, there is factor which is being added. So what is the factor? It is room sensible heat factor. And what is room sensible heat factor? Is equal to room sensible heat divided by room sensible heat and room latent heat. So if you put the values, you may get as 0.8. This 0.8 is room sensible heat factor which is fixed for this room. This room has got a fixed value of room sensible heat factor. I hope it is understood. Now if you see the psychrometry chart, you will find out a scale over here. You can go ahead and find out from the psychrometry chart. There is a scale over here apart from the humidity omega which is shown here and temperature. There is a scale over here which says sensible heat factor, which can be from 0 to 1. Okay, from 0 to 1. So, okay, or 1 to 0. Okay, so don't worry about the value. So what I am saying is, this scale, if we want to put the value of 0.8, we can always put 0.8 over here and find out and fix this value over here. So we can give a value which we have calculated, and for our analysis we can select 0.8 from here. and put a value similar like this. And there is a value here, there is a value here. So there is another parameter which I have told today, apart from dry bulb temperature, wet bulb temperature, dew point temperature, design point, apparatus dew point, relative humidity. There is another parameter which I am now adding to your knowledge, is something called sensible heat factor. And sensible heat factor is what? Sensible heat factor is equal to sensible heat divided by room total heat. So if you are talking about sensible heat factor, if you are talking about the room, then it will be room sensible heat factor. This factor can be utilized in other ways also, so it is just written sensible heat factor here. But if it is talking about room, then it will be known as room sensible heat factor. So I have told you what is room sensible heat factor and what are the things which are associated with room sensible heat factor, and it is a fixed value for a particular room for which we are going to design the air conditioning system. From there I will stop and continue in the next lecture. I hope it is understood.